So this week we'll be doing from chapter 11 again, okay? But this time we'll be doing mostly with the alter statement and the constraints. And I have it here as well a little bit, just a few pages on how to design a database, just basically because the chapter covers the PK and the FK, the foreign keys and primary key. Okay, we'll talk about that some more after the midterm. When we go to, like, we're here in Unit 7, we'll do some more based on the normalization. So this part here, I think I have a really good assignment for you guys to do as well. And so we'll do some more in that chapter after the midterm. But for tonight, we will continue from where we left off. And let me go into the learning units in here. Unit 6. I added a note in here if you want to go and look at it. It's right here. And I also put the altered statements in here as well. The basically just the syntax, okay, and a few examples, but this is syntax. As you can see, it's pretty long. Actually, it's not a complete list, but the table is pretty long. The database is also very long. But we're not going to use every little detail. Okay, so back here on this note, at the very top here, I have what I kind of don't like about the book is it lacks pictures, okay, especially this kind of class. Now, other classes maybe, but this class I think the author probably needs to put some more pictures of how we can actually visually see these objects in here. So I borrowed this from a different textbook, this picture here. So there are 3 types of constraints. You see that in the book, I think the book says there are 5 types. And if you read other books or other places, it would say 7 types or 8 types. So many types. But really just about 3 main categories. Okay, we have the domain, the entity, and the referential types. Okay, and I break these down to their own more specific types here. As you can see, we have the check and the not null. These will be applied to the domain. When we say the word domain, they really mean the columns. Okay, so in SQL Server, or actually most of the jargons for databases, domain is a column. Okay, and then we have the entity. Entity is referred mostly to roles or record. So we have a reference. A constraint on the entity would mean like something that in the a row or column that will actually apply to the entire row. In this case, you think about the primary keys and the unique columns, because that applies to the entire row, right? You cannot have 2 duplicate keys and 2 rows. So that applies to everything there. So you have this entity. So again, entity means what? The entire table, really, right? It is the actual table, the actual, in terms of object-oriented programming, is the class. And an entity should be about one single object, right? Again, based on the term here. So entity will be like a table of students. And the students is the entity. And each record is the object, right? Or the instance of that entity. So when we hear the entity constraints, usually we talk about the primary keys and the unique keys. The difference between the two is that the primary key here does not allow the null value. Okay, that is probably the major difference between the two. Whereas the unique allows a single null value. Okay, only one null value. It does not contain 2, because if you have 2, then it's no longer unique, right? So therefore you can't. Okay, and then the third type is the referential, and this is related, referred to the related tables. This is how we have a relationship between 2 tables, or well, really just 2, but you have a connection of tables. But if you really think about it, it's just between 2 tables. Okay, and sometimes 3, because you think about the types of relationships. But generally, it's the foreign key here. Okay, and this is a really important constraint, especially because when you normalize data into their own separate tables, then you might have 5 or 10 tables that would describe a single record, a huge record, like a sales record, for example, right? you sell something, you have data about the customer, data about the product, about the cost, the price, the shipping, all those stuff are related somehow to that order table. So everything is split into separate tables, and then we link things all back together through the foreign keys and primary keys. Okay, so that's why they're important. Here is a picture of, again, what those mean. So we have the domain, constraint, the entity, and the referential. Here is just the column here is it's a foreign key that would map to another primary key, right? So these are, as you can see, it's not unique in here. You have 3s in here and 4s and 4s and 4s, but really these are your foreign keys in this example here. Okay, so that's the referential. And then I show you here there's a different meanings of what they mean by entity, integrity, data, domain, and referential. So again, the word data integrity really means the accuracy, consistency, and reliability of data in the database. And we'll learn later on about this is referred to something called the acid test. So the entity again here deals with about comparing the rows in a table. Okay, you compare each row, make sure each row is unique. Pretty much that's all it is. A domain is a column. Okay, domain is columns. Usually we want to make sure that each column has a certain type of data, right? They have to match the data type. So you say column age has to be a number, then you already apply some type of constraint to that column. Okay, and sometimes you might say that, okay, a certain column can only have certain type of data, like the rating for a movie title, for example. You might have 5 or 6 different ratings only, so you apply a constraint to that as well. Okay, so that would be like the check constraints in here. And then you have the referential integrity. We have talked about that already. The only thing is that rows cannot be deleted, right? If you have 2 tables connected together, then one record cannot be deleted from the other table, depending on how you delete it first. So I also asked you a question in the assignment. How would you go about deleting that ID from the instructor or the department table, right? You know that because they are connected together, and you try to delete that record from the department table, and it didn't allow you to do it. How would you go about doing it? If you want to delete that record, how would you do it, right? So you would have to basically delete the child record first before you delete the parent. Okay. Otherwise, if you delete the parent, if that is allowed, then the child table has some orphan data, and that doesn't make sense. Okay. So that's why it's not allowed in databases. So if you have a lot of tables, and let's say you have a sales table that connects to like 10 different subtables, and those child table can have other child tables beneath it. So you can imagine how difficult can that be just to delete one sales record. You have to kind of like go from the bottom of the tree and then delete your way up there, all the way up to the main record. Okay, so again, just to protect your data from accidental deletion, because you may not want that. Again, because there's no undo button, right? So we want to make sure that those are really secure, and your data are accurate and they're reliable. And the fourth part here is the user-defined integrity. This is usually applied to like store procedures and functions and triggers. So you can write these special functions to make sure data are, they meet certain criteria before you actually add them to the database itself. So these are usually user-defined integrity. We're not gonna do much with this part here. This is more of like beyond the scope of this class, but really just these 3 up here. Okay. So entity constraints, again, these are your PK and the unique. So those 2 keywords apply to a column. So you cannot have primary key and unique in the same column. I mean, it doesn't make sense, right? It's one or the other. Not only that, each table has only one primary key. You cannot have 2 columns or more, one or more of columns have the PK. But you can have multiple columns in the same table that can be unique, right? So that is also another major difference between the primary key and the unique constraints. Okay. And the referential is again, we kind of already did that a little bit on the assignment. The referencing table and the referenced table. So those two keywords there kind of tell you which one is the child and which is the parent table. So the referencing is the one is pointing to, or depending on the other table, right? So this is a dependent table. So this is the child table, and then that one it's been referenced is the parent table. So usually the referencing table is always the foreign key. Okay, we call that the foreign key, and then the primary key is always applied to the parent table. So when you reference a table using foreign key here, you can only reference either the primary key column or a column that has assigned the unique constraint to it, because it has to be unique. You cannot just assign to any column. Okay, so only those two columns. Again, the unique, you can have multiple columns that can be assigned unique, so you can assign to any one of them. That's fine. Not only that, we'll see later on that you can actually also assign primary key to not just one column, but multiple columns. You can combine 2 or 3 or X number of columns and form a pretty long primary key as well to make that table very unique. There are times that you might have to do that, but not necessary, not always, but sometimes you do that, and so it does happen. Okay. And you can also allow, you're also allowed to do that as well. So example here, you have like the credit cards. You might have a key, 1 for Amex, 2 for Visa, and so on. So these are pretty unique, right? Just in terms of integrity, I mean primary keys. So the naming convention for your different types of keys. You'll see that in the database, you have the PK for primary key with 2 underscores. These are generated by the system automatically, because notice that when we create a column, we call ID, then int, and then we put primary key, right? We didn't specify a name. So far, I mean, that's already it's a constraint that we already kind of used it already. We just didn't maybe didn't know what it is, right? So the convention inside the studio is you have the PK, just to kind of give you that that's the primary key, followed by 2 underscores, and the name of that field or maybe table, however it's choose to do it. Usually that's the name of that table. And then underscore followed by another string of unique IDs. Okay? It's just the default. If it's a foreign key, then you have that. If it's a case for the alternate key, usually it applies to the unique key. You apply unique, and you see the character AK in there. That stands for, that means a unique. And then the CK here is for the check. Okay, so when you do a check constraint, that also has a key. And if you want to add your own key names, then you can also apply that when you create your tables. Okay, you can use that. You can use the wizard to do that, or you can do the command line. When you create a table, you can just say primary key, and then you specify a name so that it would use that instead of the default that is generated by the system. So I mean, you're not going to have both. It's one or the other. Okay, either you define it yourself, or the system will define it for you. So here are the 4 types, and indexes will deal with that later after the midterm. But these are the 3 types here. You'll see these in the studio. There is you might have seen this already. It's the row QUID column. Okay, it's a string of really long key, and this is what's called the GUID, or globally unique identifier, and every table has one. Okay, and the reason why is because the server wants to make sure that every record you have is still unique, not just across the tables, but across the entire namespace, meaning entire server. Okay, the reason is because you can have like 2 separate tables, right? Or maybe 2 separate databases, and they may have the same table, right? And you might have the same column ID, and maybe those ID can be identical, but they're separate in different databases, so they're fine. But there are times where you might want to merge 2 tables from two separate databases to a third database. When you do that, you have problems because you have duplicate data, right? Duplicate rows, duplicate records. Even though they're unique ID, they're duplicate. So this row GUI column, or this GUI ID, is to guarantee that every record you have in your database, the entire database, doesn't matter if you have one database or you have 100 of them, okay? Each record is completely unique across space. Okay? The entire server has only one ID that will apply to a single record, so that unique. So that when you merge all the data from different servers together as one database, they still work, okay? So that's the reason why they have that in there. And we don't have to worry about this one, but I just want to show you what that is. Okay, so primary keys. When you create your primary keys, you create that inside here when you create a table, right? You say your primary key and you're done. Notice again, we don't mention the name here. And since you don't supply it, the system generate that for you. Same thing with the foreign keys, right? And the alter command here is a really important, very powerful command. This is one of those commands that is part of the DDL, which stands for the data definition language. The term definition means the actual structure. You alter the structure of a table, and you altered also the structure of a database as well. Whereas if you learn, things we learned before, like the insert, update, and delete, those are only altering the data, the content, right? You're not actually changing the folder, the table structure at all. So the table will still stay the same. Even though you delete all the records, you see that the data is, the structure is still there. It's an empty table, that's all, right? But with the alter, you can actually change the structure of the table. Okay, let's just say that you create a table and a column called maybe grade. Let's just say, school grades. Maybe you had that as an int, and you want to count from grades 1 through 18 or something like that. And later on, you say, you know what, you want to change it to just to say sophomore, junior, and using words. Now, how do you go about doing that? So you can either recreate the entire table, right? If you have records in there already, that would be a big problem. Or you can alter it and just say, change the grade from int type to a varchar type, okay? So that you don't have to recreate the whole table, and you still have to do something with those grades, do a conversion type, but that's how you do it. Okay, so if you want to see what's inside, what type of constraints there are for a table, you can issue this command here, execute sp for store procedure underscore help constraint, and then followed by the table name. And that will give you those information. So while we're doing this, I also want to load my SSMS so that we can also access that as well. And as you can see, I put it here, the syntax to alter the database. You can alter the database as well. You can change the name, change the file size, or give a different name. That's completely allowed. So it's too long, I don't list it here, but if you click on this link, if you go there, you'll see that it has a long list of commands. Okay, it's pretty long. Well, not that long, I guess, for the database, but as you can see, I have all these in here. Again, anything here with the pipe symbol, it's just like or. Anything inside the square brackets are optional, right? So this is for the syntax for that. And the way how to do it is basically you say alter the database, and you give the database name, and you want to modify the file name, and you change it to you change the size in this case to 100 meg instead of what it was before, right? This is one example. We're not going to do a lot of the database alteration here, but more on the tables only. Okay, so here is again the table. The long version is here. Like this one is really long, longer than the database. Okay, so if you go here, this is the complete syntax for SQL Server and the Azure SQL. The Azure is the one, it's a cloud base, right, for the in the cloud. So you can see it's a pretty long list of all this stuff. I didn't have The one I have, the short version, does not have everything here. Like the rebuild, I didn't have that here. I didn't have the set, the switch. This is not in here. Say, okay, so we're not gonna, of course, learn everything here. You can probably take a whole week just to learn this stuff here. But the shorter version that we'll be using is mainly we see here. So you have the alter table, you give a table name, and then you can add new columns. Okay, these are all required. I put in the curly bracket, the angle brackets here. These are all required. So you give it, if you want to add a new column or a new field to your table, after you have the table already created, and let's just say, oh, you forgot to add one more column. Okay, instead of recreating the entire table, if there's no data, of course you can do that. It's very easy, right? Just delete it, drop it, and then recreate it again. But let's assume that you already have some data in there, and you have 100,000 records or something, and you want to add one more column in there. Okay, so instead of dumping all the data out and then re-enter everything manually, that's going to take you forever. You could just alter the table and add a new column. Okay, and then you also want to say allow no values. Otherwise, you will have a problem because those existing data don't have that record information in there in the column, so it will it will not allow you to add it in there. So so for now, we're just going to say add and the column name and then the data type, just like how you add when you create a table. The so it could be like age, and then int, and then over here will be if you want to make that unique or not, right? If you don't, just give it up. Or if you want to add constraint, then you would use the add constraint instead of the add column name, and then you give it a name for the constraint. Could be like a foreign key or primary key. So let's just say you create a table and you forgot to add, you forgot to make one column as a primary key, right? You can still go back and add it in there. I can say, oh, I want to alter the table called students and add the constraint of pk underscore student ID, and then you give it a primary key, and then the column name is the student ID, and then that's it. So you make a foreign key after the table has been created. And you can also add foreign keys too. After the table has been created, you can do that as well. Add constraint as the foreign key, and then the column name. Well, notice also I put a comma here. This part is or. That means same thing here with the primary key, right? You can combine multiple columns in the table to form a single. It's a compound primary key. It's a long key. So make that table still unique. And the reason why you do that is basically just for sorting purposes, okay? For the database to sort. But if you have two columns as your primary key, and if you reference as a foreign key, then you also want to make sure you also reference those two columns too. They have to match, okay? And you can also add constraint for the check. Check meaning you said that this table column can contain only the following data, right? You can say things like it has to be, the number has to be between 10 and 25, for example. You put that in there. So any value that is not within the range will be rejected, and therefore the insertion will not be allowed, okay? You can say, like, for example, this table can only contain adults, age 21 or older. You can put that in there. So age has to be greater than 21, right, or equal to 21. Otherwise, reject that. Okay. So you can add, or you can alter the column. Actually, here, alter table, and then alter column. So you can see alter twice. Okay. You want to do the table first, and then if you want to change the column to something else, this is what I mentioned, right? I had a column called grade. It was integer before. Now I want to change it to varchar. Okay, so you can do that with the alt column here. If you want to drop a column and say, you know what, I don't want to use that column anymore, I want to delete it from the table, then you can say alt table, the name, the table, and then drop the keyword column, and then you select the column name or a list of columns you want to drop from that that table, and it will drop it along with all the data. If there are data in that column, they'll be deleted too. So be careful with this one. You can also drop constraints. If you, let's just say you carry a foreign key and you want to drop that foreign key, and you just say drop constraint, and then the constraint name here, maybe like fk underscore whatever that name is. Same thing with the primary key. Let's just say I decided to not use that column as a primary key. You can go back and delete that. Okay, so you can do multiple at one time. You're not limited to just one. And this is check or no check. Okay, that means you can change the check and no check, meaning that when you add a constraint check to it, let's just say this table or this column only allows numbers greater than 21. And maybe there are certain type of people that would be allowed. Maybe they have some VIP, I don't know, special privileged people, right? And even though that person only 20 to join the club, you can say, oh, you know what, I allow you because you have a huge donor or something. So you can go and make the exception by saying alter table name, and then no check, right? That means don't check it, and then go ahead and insert that. After that, then you can insert the data in there. Age 20 is allowable. Okay, after that insertion, you want to go back and alter again. Make sure you change it back to check. Right? If you don't, it will stay unchecked for the rest of the way from there on. So just make sure you change it back. If you do this without, altering the actual table structure, okay, you just turn that on and off, kind of like how you set the identity, right? You can turn that on and off as well for manual insertion of the identity key. Okay. All right, so information about the foreign keys are here. Okay, and you add foreign keys. Let's see. Yeah, different ways to do it. All right, why don't we go into the studio here? I think it's better if you just do some examples in here.